Hi and welcome to this Key Learning Initiative video. Today's topic is simplifying radical expressions with variables and constants. In other words, we are working with square roots and how to simplify and solve them or calculate them. Before we get going, please remember to like and share this video. If you haven't already, please do join my channel, and also remember your comments are always welcome, so please do pop a comment in the comment section. So, simplifying radical expressions. We work with numbers where the product of each number's primes has already been calculated. Very important. If you're not sure how to write a number as a product of its primes, I have another video called the ladder method, making a number into the product of its primes, that will show you how to do that. But I don't want to make this video too long including that. So if you're not sure, I'll leave the link in the description section. Alright, but let's get going. Simplify the following. Example 1, and it's the square root of 36. Now most of us know off by heart the square root of 36 is 6, but I want to use an easy example to show the process. So if we write 36 as a product of its primes, it's 2 squared, 3 squared. Now we expand that fully, and so that is the square root of 2 times 2, which is 2 squared, and then 3 squared is times by 3 times by 3. Next, we group it in pairs. Because it's a square root, we group in pairs. So the first 2 we put together, and the second set of 3's we put together. That means that I have 2 times 3. Do you see how we group them in pairs to get our final answer there? 2 times 3 is 6. Have a quick look on the screen. You might even want to press pause just to see what's happening. Example 2, the square root of 3,600. Let's have a look. Again, we write it as a product of its primes. 2 to the power 4, 3 squared, 5 squared. Now, our next step is to expand it fully. So, 2 to the power of 4 is 2 times 2 times 2 times 2. 3 squared is 3 times 3, and 5 squared is 5 times 5. Now we have to group our prime factors in pairs. So our first pair of 2's, our second pair of 2's, then our pair of 3's, and then our pair of 5's. And so that equals my first couple of 2's times my second pair of 2's times my next pair of 3's times by my pair of 5's. And so I end up with 2 times 2 times 3 times 5. I put those all together, and that equals 60. And so the square root of 3,600 is 60. Again, have a bit of a look and see how I did that. Example 3, x squared y to the power of 4. And so we're not dealing with any constants or numbers or coefficients, depending on how you want to describe them. We're just dealing with variables. So what we do is we expand fully. So that equals x squared is x times x, and y to the power of 4 is just y times y times y times y. Next thing we do is we group in pairs, and so my first pair of x's I group, my next pair of y's I group, and my last pair of y's I group. That equals my first pair of x's grouped to 1x, multiplied by my first group of y's, multiplied by my second group of y's. Now, x times y gives me x y squared. That's when we just have variables and no numbers. Let's look at example 4, where we have both numbers and letters, a coefficient and some variables. First step here is to make sure we take 49 and we write it as a product of its primes. Well, that equals the square root of 7 squared, that's 49, y to the power of 2, z to the power of 4. The next step is we expand fully, so that equals the square root. 7 squared is just 7 times 7. Y squared is times y, and z to the power of 4 is just times z times z times z times z. And we've expanded it fully. Now we group in our pairs. Our first set of 7s we group together. Our first couple or set of y's we group together. Then the first pair of z's and the second pair of z's we group together. That now equals our 7 multiplied by our group of y's multiplied by our first group of z's multiplied by our second group of z's. That now equals 7 y and z times z is z squared. Again, if you'd like to pause and just have a look and see how it goes or how I did it, please feel free to. So thank you for watching this Key Learning Initiative video on simplifying radical expressions with variables and constants. I hope it has been helpful. Please remember to subscribe to my channel for more updates and more videos. Please remember to leave a comment in the comments section, and I hope this video has been very helpful for you.